everyone. So today we're just going to quickly review the vertical angle theorem and perpendicular lines. So in Unit 1, I actually introduced you to the vertical angle theorem. And I just want to remind you that the vertical angle theorem says that vertical angles are congruent. And we know that vertical angles, that means that vertical angles are equal to each other, but we kind of have to remember what vertical angles are. And what's going to get challenging here is that you really have to take some time and make sure you understand in a picture where vertical angles are, where linear pairs are, and we're going to be adding on to that as we go. So as a reminder, vertical angles are when you take two lines and you kind of cross them. And their sides, the sides of the angle, so those are the sides of this angle right here. Their sides are opposite rays. So there's this line right here. This segment's or this ray's opposite ray would be this one. And this one's opposite ray would be this one. So these two angles would be vertical and they'd be congruent. And these two angles would be vertical and they'd be congruent. You have to be very careful when the diagrams get a little bit trickier. All right, so when we look at a diagram, if we're given this diagram, then the angles are congruent, so we mark them congruent. That allows me, congruent means equals, allows me to write an equation. So in this case, x squared equals 12x minus 36. Okay, so at this point you should be asking yourself, what type of equation do I have here? I can almost hear you say it. Thomas, you out there saying it? What is it? It is a quadratic equation. Okay, it's a quadratic equation, so we need to get it set equal to 0 and solve by factoring. Now remember, you might not always be able to factor things, and that would be when you choose the quadratic formula. But for now, I'm giving you factorable equations. So I'm going to subtract 12x to both sides. I'm going to add 36 to both sides, and I'm going to get x squared minus 12x plus 36. Now, some of you might recognize this as a perfect square trinomial, but others might not quite yet. Remember, a perfect square trinomial is when the first term and the last term are perfect squares. The last term is also positive, and the middle term, that 12, is double the square roots of the outer terms. Now, if you factor it, you're going to get x minus 6 and x minus 6, which also tells me it's a perfect square trinomial, because if I went directly from that to factoring, I would get x minus 6 squared equals 0. All right, so in this case, I use the zero product property. I only have to set one factor equal to 0, so x equals 6. I only have to set one factor equal to 0, so x equals 6. All right, so what do we want to go on to next? We want to go back to that idea of perpendicular lines that we've been talking about. So remember, perpendicular lines are two lines which meet at right angles. The symbol for perpendicular is an upside down T. Well, that kind of makes sense because it's kind of two lines, and so then we also would put a box there to indicate that the lines are 90 degrees. So they meet at right angles, and which means they form a 90-degree angle, because a right angle is a 90-degree angle. Okay. All right. So let's put all of this together. So I give you this diagram, and it says in the above diagram, so BE is perpendicular to AC. So BE is perpendicular to AC. So I'm going to put a right angle right here. Now, there's also a right angle right here, but I tend to only do it on one side because it gets really confusing and lots of lines, okay? But I'll leave that one in there. And then it says that BD, so this ray right here, and BF are right angles. So this is a right angle. See, already confusing. All right, so let's find the measures of the following. So it says CBF, so this angle is 40 degrees. So if this is 40, and we have this red right angle, that tells me right away that EBF has to be 50, because 50 plus 40 gives me 90, okay? All right, and if this angle is 50 and this blue box is 90, that tells me this has to be 40. And if I have this black right angle and this is 40, then this would have to be 50. So I basically have just solved everything, But now I want to go back and go through each answer and see what they're looking for. So the first one says the measure of angle EBF, so this angle right here, which we said was 50 degrees. DBE was this angle right here, we said was 40 degrees. DBA, we said was 50 degrees. All right, now DBC. All right, so let's look carefully here. From D to B to C. So that means I want all of these angles added up. I'm going to use the angle addition postulate, and I'm going to do 40 plus 40 plus 50. So 80 plus 50, which is 130 degrees. So it is an obtuse angle, and it even appears to be obtuse. All right, so that's how you use perpendicular lines and vertical angles. Now this can get a little bit trickier when I throw in other figures. So we've talked about an isosceles triangle before, but I want to define it again. An isosceles triangle is a triangle that has two congruent sides. We call them the legs. So here's an isosceles triangle, and I'd mark these legs congruent. I could also do this and say these are the two congruent sides. So you just have to be really careful. But the interesting thing about isosceles triangles, which we're going to learn a bit later, is that their base angles are congruent. Their base angles are the angles across from the congruent sides. So this angle and this angle, or this angle and this angle. And again, they're across from the congruent sides. So this question says, the following diagram shows an isosceles triangle. Find the value of x in degrees. All right, well, first I would have marked this because I would have wanted to know which sides were congruent. So I probably should have marked that on your diagram for you, showing that it's an isosceles triangle. So then I know that these angles right here are equal. So I know that this angle right here is 75. Then I can clearly see that I have two vertical angles. So I'm going to mark this congruent as well. So then x plus 20 equals 75. Subtract 20 from both sides, and x equals 55. All right, so that's one way we can use this idea of a vertical angle within another figure. The last thing I want to circle back to is the idea of complementary and supplementary angles. Two angles are complementary. It means that they add to 90 degrees. All right, so this question says the measure of the larger angle is 5 times the measure of the smaller angle. Find the measure of the larger angle. We always want to start these by writing a let statement. So we are going to let x equal I always go for the smaller angle because it makes it easier. So I'm going to let x equal the smaller angle. And that way, 5x is going to equal the larger angle. Don't have to do it like this, but otherwise, that way, if you did it the other way and you let x be the larger angle, you're going to have a fraction. And I don't like fractions. All right, so I know that these two angles have to add to 90. So x plus 5x equals 90. So 6x equals 90. And x equals, let's see, 15. So this is 15 degrees, and the larger angle would be 75 degrees. All right, guys, what I'd like you to do is I'd actually like you to try 2 and 3. See what you can remember, kind of quiz yourself to see what you remember about those complementary and supplementary angles, and see if you can come up with word problems. And we're going to go over them tomorrow in class. I hope you have a great night.